In the previous lectures and all, we discussed about homogeneous and non-homogeneous differential equations, and also about the non-homogeneous equations of the type exponential functions, trigonometric function like cos ax and sin ax function, and also the polynomial equations. So now, apart from these type of equations, if you have a function like tan x, secant square x, logarithmic functions is there means, so we'll see how to solve those kind of differential equations in this concept. So here I'm going to solve this kind of equations by using method of variation of parameters. So we'll see how to solve the differential equations here and few examples related to the method of variation of parameters. So the step 1 is, so given the function is like this, f of d into y is equal to pi of x. So where f of d is nothing but an differential equation or operator equation. Now the first step is we have to write the complementary function for the given differential equation f of d y is equal to pi of x in the form yc is equal to c1 y1 plus c2 y2. So after finding the complementary function, assume the equation like this, y is equal to a into y1 plus b into y2. So just I am doing some small rearrangement by replacing the constant c1 by a and constant c2 by b. But note that here a and b are functions of x and y. So those are functions, not constant actually, it's the functions of x and y. Just I am replacing it as a and b, that's it. So I'm going to assume that that's the equation y is equal to a y1 plus b y2 will be the complete solution for the given differential equations. So it means that we have to estimate the values of a and b here in terms of x. So step 2. So we have to compute y1 dash and y2 dash. So from the complementary function, choose the value of y1 and y2. Compute y1 dash and y2 dash. In the sense, differentiate y1 and y2 with respect to x to get y1 dash as well as y2 dash. After finding y1 dash and y2 dash, find the value of Wronskian w. It is given by y1 y2 dash minus y2 into y1 dash. So on simplifying this equation, we'll get the Wronskian. So after finding the Wronskian, we have to compute a dash and b dash. So we assume the expressions for a dash and b dash in the form a dash is equal to minus y2 pi of x by w and b dash is equal to y1 pi of x by w, where this pi of x is obtained from the given equation. So and we have to simplify the equation also. So to find a and b, since here a dash b dash is there, to get a and b we have to integrate a dash and b dash. So we'll get the values of a and b. Step 4. So after finding this a of x and b of x, replace this a of x and b of x in the assumed complete solution a y1 plus b y2 to get the solution for the given non-homogeneous differential equation. So these are the 4 steps involved in solving the problems by using method of variation of parameters. So now we will see few examples related to the method of variation of parameters. The first example is solve the method of variation of parameters y double dash plus a square y is equal to secant ax. So we can observe that here the function is secant ax. So here we can't use type 1, we can't use type 2 also, we can't use type 3 also. So I am going for the method of variation of parameter concept. So according to step 1, the first step is we have to find the complementary function. So to find the complementary function, we have to make an auxiliary equation and we have to find the roots. So to make an auxiliary equation, I am going to replace d terms by m. So I got the equation like m square my plus a square is equal to 0. On simplifying this equation, I got m is equal to plus or minus ai. So the roots are complex here and with the real part equal to 0, the complementary function will be yc is equal to c1 cos ax plus c2 sin ax. So now after finding complementary function, I am going to assume the complete solution for the given differential equation like this. Y is equal to a of x cos ax plus b of x sin x. Thus I am replacing the constants c1 and c2 in terms of a of x and b of x. So now we need to compute the a of x and b of x. So already we know the formula for a of x and b of x. So before that we have to compute Wronskian. So to compute Wronskian, choose y1 and y2 from the complementary function. So y1 is cos ax, y2 is sin ax. So we have to differentiate both y1 and y2. So we'll get y1 dash. So differentiating y1 will get minus a sin ax. Differentiating y2 will get y2 dash, that is a cos ax. So replace both the values in Wronskian. W is equal to y1 y2 dash minus y2 y1 dash. So on simplifying, the equation will get the value a. So also the given pi of x will be secant ax here. So replace all these values in the a dash formula and b dash formula. A dash formula is given by minus y2 pi of x by Wronskian. B dash is given by y1 pi of x by Wronskian. So y2 is sin ax, pi of x is secant ax by a. B dash is cos ax, pi of x is secant ax by a. So we know that secant is nothing but 1 by cos. So we'll get sin by cos. So sin by cos is tan ax. I got a dash is equal to minus tan ax by a. So same thing in b dash also. Secant ax is cos ax. Cos ax gets cancelled. I got b dash is equal to 1 by a. So now to compute a of x and b of x, I'm going to differentiate the equations. Integrate the equations with respect to x. So I will get the equation like a is equal to minus 1 by a integration tan ax dx plus k1. I'm taking the constant k1 here. Plus b is equal to 1 by a integration dx plus k2. So on integration tan x will get minus log secant ax by a. Already 1 by a is there. So I got the equation like a into minus log secant ax by a square plus k1. B is equal to x by a plus k2. So substituting these values in the equation number 1, we'll get the equation like y into, in place of a, I'm replacing the value of a of x. In place of b of x, I'm replacing the value of b of x. So I got the equation like y is equal to minus log secant ax by a square plus k1 into cos ax plus x by a plus k2 into sin ax. So on expanding this equation, I'll get the equation solution like k1 cos ax plus k2 sin ax minus cos ax log secant ax by a square plus x by a sin ax. So we can observe that here. So this solution is of the form complementary function plus particular integral of the form. So this is the required solution for the given non-homogeneous differential equations. One more example. Solve d square y by dx square plus y is equal to tan x by method of variation of parameters. We have the equation like d square plus 1 into y is equal to tan x. The auxiliary equation will be m square plus 1 is equal to 0. So the first we have to make a complementary function here. So for that purpose I am making the auxiliary equation, that is m square plus 1 is equal to 0 by replacing d is equal to m. So on simplifying the equation I got the roots like m is equal to plus or minus I. So since it is a complex roots with the real part 0, I can write the complementary function like yc is equal to c1 cos x plus c2 sin x. So let y will be now a of x cos x, b of x sin x be the complete solution of the given differential equation. So after finding the complementary function, I'm going to assume the complete solution like this here. So I'm going to call it as equation number 1. So now to find the Wronskian, choose y1 and y2 from the complementary function and find y1 dash and y2 dash. So we have y1 is equal to cos x, y2 is equal to sin x. y1 dash will be differentiating y1 with respect to x. I got minus sin x. y2 dash will be differentiating y2 with respect to x. I got cos x. So replacing these values in the Wronskian, w is equal to y1 y2 dash minus y2 y1 dash, and simplifying it I got the solution like 1. And the pi of x is given like tan x here. So on replacing all these values in the a dash and b dash formula, so a dash is nothing but minus y2 pi of x by w, b dash is y1 pi of x by w. Replacing the values now, a dash is equal to minus sin x tan x, b dash is cos x tan x. Tan x is nothing but sin x by cos x. On simplifying the equation I will get minus sin square x divided by cos x. B dash is nothing but again simplifying tan x, I am having sin x by cos x here. Cos get cancelled, only sin x I got it. So now on integrating the equations a dash and b dash to get the value of a of x and b of x, I'll get the equation like this. A is equal to integration of minus sin square x by cos x dx plus k1. So since I can't expand sin square x by cos x, I'm going to rewrite sin square x as 1 minus cos square x according to my convenience for the simplification. And also b will be same as it is, integration sin x dx plus k2. So on expanding 1 minus cos square by x, I will get the equation like 1 by cos x minus cos square by cos x. So on simplifying this by taking negative inside, I can write the equation like a is equal to integration of cos x minus secant x. So secant x is obtained by 1 by cos x into dx plus constant k1. So b will be obtained by integrating sin x, that is minus cos x plus k2. On integrating cos x here in the a function, I got sin x. Secant x will be log secant x plus tan x plus k1. So I got the solution for a like sin x minus log of secant x plus tan x plus k1. B will be minus cos x plus k2. So now I can replace these two values in the complete solution, equation number 1. So I got the solution like y is equal to sin x minus log secant x tan x plus k1 into cos x plus minus cos x plus k2 sin x. So on simplifying this equation, we will get the solution like y is equal to k1 cos x plus k2 sin x minus cos of log secant x plus tan x. So here that cos x sin x minus cos x sin x gets cancelled. I got this solution for the given differential equation by using the method of variation of parameters. So here I gave 2 problems for the assignment. So all these 2 problems, and if any doubt is there means please give comment in the inbox so I can reply for the same. Thank you.